So let's take a look at problem 11-10 next. I'm going to read the problem out. A miter saw blade is braked from 4,800 RPM to a stop in 1.5 seconds. Calculate the deceleration rate and the number of revolutions turned during the braking. Okay, so it's braked from, that means initial angular velocity is 4,800 RPM and to a stop, so that means final velocity is 0 in a time t is 1.5 seconds. We need to find angular acceleration and we also need to find theta. So by the time it has stopped, how many revolutions has it made? Okay. So for this, we already know the formula that involves final velocity, initial velocity, and time. Okay. So, but before we do that, we have to do this one thing that we need to do frequently, which is convert RPM to radians per second. So 4,800 times. So let me. Revolutions per minute times 1 minute as 60 seconds times 1 rev is 2 pi radians. So all said and done, this comes to 502.7 radians per second. So if you think about it, basically what we've done is, if you want to remember, is like in the test or anytime you want to save time, basically the numbers are like this: RPM times 2 pi over 60, right? That's what it comes to once you cancel out these things. RPM times 2 pi over 60. Okay, so that's what it comes to, and then we have this radians per second. All right, so we need to find the acceleration. It is what? 0 final velocity minus initial velocity, 502.7 divided by time 1.5. So that comes down to negative 335.1 radians per second square. Okay. Now we need to find how many revolutions it has completed while slowing down. Okay. So same formula here, S equals ut plus half at square. So this becomes theta equals omega naught t plus half alpha t square. So theta equals omega naught t plus half alpha t squared. Theta, omega naught is 502.7 times 1.5 is the time, plus half alpha is what? Negative 335.1 times 1.5 square. So when you calculate all of this, and I urge you to check my arithmetic, okay, 377 radians. Okay, 377 radians. Now it is hard to understand radians in terms of, you know, in intuitive terms, so we need to convert that radians to revolutions. So this saw, which is going at 4,800 RPM, you have stopped it in 1.5 seconds. In 1.5 seconds you have completely stopped it. So in this process, how many revolutions has it made? So it has made 377 radians, but we need to convert now radians to revolutions. Let's see. So 377 radians. Okay, now 1 radian, right? 2 pi radians is 1 revolution, right? So we need to write this in such a way that the radians cancel out. So 377 over 2 pi, that's roughly equal to 60 revs. Okay,